obviously according to that, what will happen, that specific product will be created, or that specific product will be get printed out. So that is the point in energy means environmental benefit. Now inventory stock reduction. With additive manufacturing, components are printed on demand, meaning there is no overproduction, no unsold finished goods, and reduction in inventory stock. So this will be the fifth point. Now legacy part. Legacy. Additive manufacturing has gifted companies the ability to recreate impossible to find, no longer manufacture legacy part. Suppose if you have a old car, and that will be a legacy, okay, and that one part is get means that one part is get damaged. So to create that, you can use the 3D printer scanner, scan that object and create it by the help of this 3D printing machine. So it is written that AM has a gifted company the ability to recreate the impossible to find, no longer manufactured legacy part. For example, the restoration of classic cars has greatly benefited from additive manufacturing technology. So anything have been damaged from your old car, that can be manufactured by this 3D printing machine. Where legacy parts were one difficult and expensive to find, they can now be produced through the scanning and X-rays analysis of original materials and part. As you can see in the previous diagram, I show you that by the help of the 3D printer scanner, we can scan the object and manufacture any of the product which are not possible that by this conventional manufacturing. So in combination with the use of CAD software, the process facilitates fast and easy reverse engineering to create legacy part. So any legacy part you want to create, by the help of this 3D printing machine, you can easily create that. So these are the advantages of additive manufacturing. The next point is manufacturing and assembly. A significant benefit of additive manufacturing is to ability to combine existing multi-part assembly into a single part. Instead of creating individual part and assembling them at later point, additive manufacturing can combine manufacturing and assembly into a single process. So obviously you know that in conventional machining we have to create, if you want to create a 3D model, we have to create it part by part, okay, and after that we have to assemble that. But in 3D printing machine, that stages we won't have to follow. We can directly create a 3D model, effectively consolidating manufacture and assembly into one. So obviously we know that the material will be created layer by layer, so we will get the final product according to that. The last point is material waste reduction. Material waste reduction. In conventional manufacturing process, material is typically removed from largest piece of work, think timber milling or cutting shapes from sheets of steel. In contrast, AM start from scratch, adding material to create a component or part. By using only the substance necessary to create the part, AM ensure minimal waste. AM also reduce the need for tooling, therefore limiting the amount of material needed to produce components. So obviously whatever product you want to create, only that product will be manufactured in 3D printing machines. No waste material there will be no wastage, okay. So whatever design you have created, according to that design will be get ready. So therefore there will be a material waste reduction. There will be no waste will be not happening in 3D printing machines. Then part flexibility. Additive manufacturing is appealing to companies that need to create unusual or complex components that are difficult to manufacture using traditional process. Additive manufacturing enables the design and creation nearly any geometric form. Once that reduce the weight of an object while still maintaining stability. Part flexibility is another major waste reduction aspect of additive manufacturing. The ability to develop products on demand inherently reduce inventory and other waste. So obviously previously we have seen on the slides that sharp contours which are not achieved by this conventional machining, it possible by the help of this additive manufacturing or 3D printing machine. So it will be possible to achieve that sharp contours and complex component part we can achieve easily by the help of these 3D printing machines. Okay, now part reliability, small components and those intricate parts or small moving pieces typically require strict manufacturing tolerance and very controlled assembly processes. Additive manufacturing method help to reduce number of component defects and improve part reliability. Additive manufacturing technology allow manufacturer to print entire component with precise tolerance, thereby improving part reliability and product quality. So whatever tolerance you want in a 3D printing machine, you can easily achieve by the help of 3D printing machine as compared to the conventional manufacturing. So that will be a beneficial, or part reliability are the advantages of additive manufacturing. Now come to the disadvantages of additive manufacturing. So cost of entry, obviously first point come your cost of entry. With additive manufacturing, the cost of entry is still prohibited to many organizations and in particular smaller business. The capital cost to purchase necessary equipment can be sustainable, and many manufacturers have already invested significant capitals into the plant and equipment for their traditional operation. Making the switch is not necessarily an easy proportion and certainly not an inexpensive one. So obviously they are using a conventional machining. Why they will change to additive manufacturing? There will be loss. So obviously that will be come under this disadvantages. Cost of entry means many companies are now using CNCs and conventional machinings, so they don't want to change, means they don't want to here it is written they don't want to invest in this. So that will be a cost of entry, will be the disadvantages for 3D printing machines. Next, production cost. Obviously the production costs are high. Material for additive manufacturing frequently required in the form of exceptionally fine or small particles that can be considerably increase the raw material cost of a project. Additionally, the inferior surface quality often associated with additive manufacturing means there is an added cost to undertake any surface finish and the post processing required to meet quality specifications and standards. So obviously production means obviously we were using some type of material that will be cost, material cost will be high, so that will be comes under the production cost will be getting high. So that will be your disadvantages in additive manufacturing. Now next use your additional materials. Currently there is a limit to the type of material that can be processed, means in CNC machine or any type of conventional machining you can create any type of object, any type of material you can means create. But whenever it comes to the 3D printing or additive manufacturing, what will happen, there will be a limitation, means we cannot create all type of material, there will be a limitation of material, type of material. So AM specifications, and these are typically pre-alloy materials in a base powder. The mechanical properties of a finished product are entirely dependent upon the characteristics of the powder used in process. So obviously we know that we use powder material or plastic material to create this 3D printing object. All the materials and traits required in an additional manufacturing component have to be included early in the mix. It is therefore impossible to successfully introduce additional materials and property later in the process. So these are the additional materials, means there will be a limitation, whatever you want to add the material you cannot add in 3D printing machines. So there will be a limitations of material. Now last point is it is slow. As mentioned, additive manufacturing technology has been around since 80s, yet even in 2021 AM is still considered as niche process. That is largely because use AM still has a slow build rate and does not provide efficient way to scale operation to produce a higher volume of parts. So whatever object, whatever 3D model you have create, it will take time. Okay, so it build quality is very slow. So this will come under the disadvantages. Depending on the final product, short additive manufacturing may take up to 3 hours to produce a shape. Okay, so obviously it will return that 3 hours to produce a shape that a traditional process could create in seconds. So obviously if you want to create a shape in whenever you go to the traditional machining, it will create in seconds, but that shape will be created in 3D printing machine and it will take around 3 hours of time. It is virtually impossible to realize economies of scale. Then the last point is your post processing. A certain level of post processing is required in additive manufacturing because surface finish and dimensional accuracy can be lower quality compared to the manufacturing methods. So obviously if we compare our model with conventional manufacturing like any other CNC machines, so obviously we will not get that type of surface finish on dimensional accuracy. So obviously depending upon your CAD model, where what design you have created, according to that you can get a good quality of 3D model. Then the layering and multiple interference of additive manufacturing can cause defect in the product, whereby post processing is needed to rectify any quality issues. So obviously post processing also we have to, means after the object is created we have to do the post processing, means if we have given any type of support, any type of means we have to create any type of surface finish, so we have to lastly we have to follow the post processing process. So that will be not required in conventional machining. Okay, so that will come under the disadvantages. Now commonly used terms, as we know that means additive manufacturing, different names are 3D printing machines and rapid prototyping. There are other names of additive manufacturing like additive manufacturing, additive layer manufacturing, additive digital manufacturing, like layer based manufacturing, layer oriented manufacturing, layer manufacturing. So these are the different terms used for additive manufacturing. Now, then rapid technology, we can call it as rapid prototyping, rapid tooling, rapid manufacturing. We can also call it as digital fabrication, digital mockups, and we also know that additive manufacturing is known as 3D printing, 3D modeling, direct manufacturing and direct tooling, means we take a nozzle and directly impinge on the whatever material we have taken, we will impinge that on layer by layer manner. So these are the commonly used terms used for additive manufacturing. Now comes to the leaders in additive manufacturing. There are three different points as given: 3D printer manufacturer, 3D printer users and consortiums. Okay, so in 3D printer manufacturer there are EOS, Statistise, 3D System, HP and GE, which will manufacture these 3D printers. Now coming to 3D printer users, NASA. Who are the users? NASA, GE, Siemens, Airbus, Boeing, Ford, Volvo, BMW are the users of 3D printers. Now they have initially used this 3D printer. Then if we see in the next slide, NASA has already been used this 3D printer in space. So it is being experimented within the space by NASA. The first 3D printer is not intended for mission use. It is not intended for mission use. It is a technology demonstration experiment. The full title of the experiment is 3D printing in 0G technology demonstration. So they have just taken it for a experiment purpose in space. Then a future permanent payload for ISS is the additive manufacturing facility. The intent of the AMF is to provide the crew with the ability to perform station maintenance. So obviously this 3D printing is used for perform station maintenance, build tool and repair sections of the station in case of an emergency. If there is any type of emergency, so they have a scanner, they can scan the object and according to that they can create a 3D printout. Okay, then this will include an extrusion based 3D printer capable of producing components for a selection space rated composites. While clearly benefit the ISS, the capability will be essential for long term deep space missions such as sending a crew to Mars. So obviously 3D printing has been implemented on space also. by NASA. Then GE is one of the big company because of which metal 3D printing actually become famous. So GE is the first company that has created 3D printing metal, okay, metal 3D printing, and become famous. GE launched a leaf engine which was the first successful fuel nozzle, fuel nozzle and commercial certified 3D printer metal part application. This made a lot of noise back in 2015. Everybody was going crazy about it. Everybody used to talk about it because this was the first successful application. They have 20 different parts which are consolidated into just one simple part. Okay, so they have created a metal 3D printing with 20 different parts and they have created into a one, and which saved them a lot of cost and lot of lead time and lot of quality issue during production. So GE is the first metal 3D printing company to use this 3D printing users. They are the first user to use the 3D printing metal. Okay, then next is Siemens. Siemens is another company which is into the making turbine, exploring can we make gas turbines through 3D printing. So obviously Siemens are the company which exploring turbines. They are making turbines by the help of this 3D printing. Last is your Airbus. Airbus has its own specific material developed for 3D printing which is superior to the conventional grade and could not have been made through conventional process. So obviously Airbus has been Airbus is also using this 3D printing machine. Then Boeing has already launched the satellite part with NASA which has 3D printed, and Ford, Volvo, BMW, all these are adapting 3D printing for either prototyping or of cars or actually making the end product. So obviously Boeing and Boeing with the help of the NASA, they have created which have created by the help of 3D printers. Ford, Volvo, BMW also we have given the example in transportation that the cars will be manufactured by the help of these 3D printing machines. So this will be possible by the help of this 3D printing machine. Then last second is for Volkswagen. Volkswagen had a great shift gear knob 3D printed in all the cars in Germany starting last year, working with HP. They collaborated with HP and created a gear shift knob which was created by 3D printing machines. Then last is your consortiums. Consortiums are very important because so we have America Makes is one of the big consortiums which has launched back in 2015, and another name is NAMIC. NAMIC is another consortiums which was in Singapore. What these consortiums are doing, they are just they are just make it faster, means they are obviously the manufacturer users find out to how to make this process more effective, means this 3D printing machines how to make this effective. These consortiums are focusing on that. So how to make it faster, better efficient energy, cheaper. So all these things actually happening in these consortiums and the effort that they are putting together. So there are multiple joints research, they even call universities together and have a very good projects around 3D printing to make everything better. So consortiums are arranging all this by all these to means obviously to enhance the capability of this 3D printing machines. So for today this is it. Thank you so much.